So when I set up the activity sheets, the first category, it says purpose of activities, but that's not for you to do. It's just listing what you're going to be doing in the activity. And then below that, I set up equipment needed, and that's more for me to get everything together, to have it ready for you guys. So the activity actually begins below that in the next section where it says identify and describe the following. So what I'd like to do is have each one of you read. And then after you read it, I'll add my 2 cents, and then I'll show you how to do whatever it's talking about.
Okay.
Allison, do you want to start reading?
From which point on?
Expiratory
Right here?
Filter.
Okay. Identify and describe the following. Inspiratory Filter. Follow the manufacturer's guidelines for the type of bacteria filter to place on the inspiratory port. The filter traps bacteria and viruses that are 3 microns in size and larger.
So a bacteria filter looks like this, where there's just that thin piece of, looks like gauze in the middle, and that's going to filter out any bacteria or debris that's 3 microns in size or larger. So when we put it on the inspiratory side, it's air that comes from the gas outlets, travels through the ventilator, and then goes into the patient's circuit. So it's not going to have any contamination in it, because that's just cold, dry air that's coming through. And the internal components in the ventilator don't get contaminated. So this is a lower level filter, but it's perfect for the inspiratory side.
So air through filter out.
So you'll be hooking up to oxygen and air, not this week, we do that next week. The hoses come into the side of the ventilator, you push the air in the ventilator, and then it'll go to the patient. Okay, what's next?
Inspiratory limb tubing. The inspiratory side of the circuit brings a fresh flow of gas from the ventilator to the patient. Identify the inspiratory side by locating the temperature sensing port.
Okay, so when you're putting a circuit on a critical care ventilator, it'll have 2 tubings, the inspiratory tubing and the expiratory tubing. So here the inspiratory tubing is blue, but you can't always count on colors, because if they switch manufacturers, it could be different colors. The inspiratory could be clear. So how are you supposed to know the difference between the 2 tubings?
The port.
Yeah, you look for the temperature sensing port, and you're always going to be sensing temperature on the inspiratory side. So wherever this is located, that's your inspiratory tubing.
Expiratory limb. The expiratory limb is connected to the ventilator, and exhaled gas from the patient will go inside the ventilator where the exhalation valve is located. Although not visible, the valve closes during inspiration, so the flow of gas can only go into the patient's lungs. It opens on exhalation to allow the gas to leave the patient's lungs. It also has transducers which monitor flow, pressure, and volume.
Okay, so the expiratory limb is when the patient exhales, the only way the air can flow is through the expiratory tubing. When you look on this ventilator, it's got a picture and it says INSP for inspiration. So that's where your inspiratory tubing will go. And then what does it say for the other one? EXP for exhaled air. So that's where you'll connect your expiratory tubing. So what we can't see is this cassette. I can show you like the outside of it. So this is called the expiratory cassette, and this is where everything's being measured. The pressures, the flows, the volumes inside. This is our exhalation valve, which is being controlled by the ventilator. And so when the patient exhales, their air will go out into the atmosphere from here.
Expiratory water trap and expiratory filter. The purpose of the expiratory water trap and filter is to collect condensate and other liquids. This will help to prevent the exhalation valve assembly from getting moisture on it. Moisture can interfere with the accuracy of the measurement of exhaled air.
Okay, what we're going to use is this expiratory filter. I don't know if you want to call that a water trap, but it does accumulate any moisture and condensation, so you will see it in here. So I guess we'll call that our water trap. This is considered a HEPA filter. So when the patient exhales, if they have COVID, if they have, what are all the other viral
C. diff.
infections?
Is C. diff?
That's in the intestines.
Okay, another, you have
Pneumonia?
RSV maybe?
So maybe MRSA,
MRSA, TB.
TB. When they exhale their air, it'll get stuck in the HEPA filter, and it won't go inside the ventilator and come out into the atmosphere.
Yeah, that'll be bad.
That would be bad.
You're holding it in that orientation. Is it orientation dependent?
Yes. Yeah, because the water will go down.
Sitting on its side or hanging it.
Right, so putting it like this is a no-no. You want to have the water trap at the bottom.
Now, is there a way to release the water or the condensation or liquid that forms in there, or do we have to completely change out that filter?
You'd throw it out.
You throw it out
Put
completely.
another one in
Got
it. Yes.
And how long does it usually take to throw those out?
For these, you throw them away every day and put a new one in.
Okay.
Because if a lot of moisture builds up in here, it
Bacteria.
restricts the flow of air leaving the ventilator and leaving the circuit. So when you put it on, you'll have a marker with you and you'll write the date, like change on, and then put the date. So HEPA filters filter 0.5 microns and larger. The bacteria filter 3 microns and larger. So that's the difference between them.
The Y and rebreathe air. Find the Y and patient circuit. Air in the ventilator circuit that is between the Y and the endo tube is rebreathed by the patient. For this reason, it is also referred to as dead space. Describe the devices that can cause dead space to increase.
Okay, so the Y. Can you see how this kind of looks like the letter Y? Mm-hmm. So that's how it got its name. They put a W in the front and an E at the end, and they made it a word. But it looks like the letter Y. So when you have fresh air coming in, it goes to the patient. This isn't here.
Oh, that's not
Goes to the
supposed to be.
patient, and then when the patient exhales, it goes out the expiratory tubing. So when you have, let me add a bunch of stuff to it. Tubing, make it long, exaggerate the point. So we have a fresh supply of gas coming to the patient, going into their endotube, their trach tube, and then the patient exhales. Their exhaled air will fill this up, it'll fill this up, it'll fill this up, and then go out this way. Now it's time for the next breath. The next breath will come in and push all this air back into their lungs. So between the Y and the patient, that's all considered rebreathed air. And another name for rebreathed air is dead space air.
Rebreathe air. And is that oxygenated?
There's a little bit of oxygen in exhaled air.
Is that also called mechanical dead space?
Yes.
So are they rebreathing their CO2?
Yes.
Yes.
Oh.
So you could never put like 5 feet of tubing here because they would just keep
Never get a good
rebreathing that
breath.
air. Yeah.
So between the Y piece and the endo
Tube.
tube is called rebreathed air.
Yes.
Explain why it is necessary to have no leaks in the circuit. Instead of the air entering the patient's lungs, the air will exit through the leak in the circuit. This will cause less air delivery to the patient's lungs.
When you put the circuit under pressure to deliver the positive pressure breath, if there's any openings or if you don't have a tight connection, air will go out there instead of going into the patient's lungs.
So you lose volume and pressure?
Yes, very good.
I remember that.
Good job. Yeah, so that's one thing that you're always checking, is if you notice that your VTI, your VTE are different and you're missing volume, you check your circuit, make sure everything is, push and twist to make sure it's tight.
How should a ventilator circuit be handled to prevent contamination? Use a clean technique and only touch the outside of the circuit. The inside of the circuit must be kept free of any contamination. Handle the circuit carefully to prevent the ends of the circuit from touching any objects.
All right, so this circuit, probably for Chris it's not a problem, But for me, it's about as tall as I am. So if I don't pay attention, I'll be dragging the ends on the floor. And we don't want that to happen. I mean, you could take a cavi wipe, disinfect the ends, let them dry, and that's okay. With children, infants, no. If it touches the floor, you put it right in the garbage and get a clean one because their immune systems are not like that of an adult. But the best thing is don't let it touch the floor. So how do you do that? You use the ventilator arm to support it while you're working on it. And it goes into these holders. It's crazy because it kind of squeezes the tubing, like stirrups, yes. So you put the circuit on the arm first, and then you do all of the connections.
How often should a ventilator circuit be changed? The Center for Disease Control recommends the circuit be changed on an as-needed basis, PRN. If the circuit is visibly soiled, it is recommended that the circuit be changed.
So it used to be believed that the circuit is what contaminates the patient, and don't leave it on the patient more than 24 hours, because if you do, they'll get pneumonia. And then years go by, and they realize, no, the contamination isn't coming from the circuit. It's coming from oropharyngeal secretions that drip down around the cuff and get into the lungs. So that's why when a patient goes on the ventilator, they end up getting pneumonia a day or two later. It's all those oral secretions that are dripping around the cuff and getting into their lungs. So now you don't change this every day. Like we used to have to change it every 24 hours. Now it's only if it's soiled. So if you see blood or secretions in
What is a
it.
ventilator circuit disposed of? Ventilator circuits are for single patient use. Some added devices may be reusable and need to be sterilized before use on another patient. A used circuit may be disposed of in the regular trash, however, note the following exceptions. If the circuit has visible signs of blood, the circuit needs to be disposed of in a red bag. Red bag contents are incinerated instead of going to a landfill for disposal. If a patient is in isolation for any reason, their circuit needs to be disposed of in a red bag.
Yeah, you'll see garbage cans with red bags in them when you're at the hospital. And anything that goes into those red bags don't go to a landfill. Instead, it goes to an incinerator and they burn it, which is expensive. So they don't want you throwing everything into red bags, only stuff that's contaminated. So if you have a patient in isolation, yes, everything with that patient goes in the red bag. Ventilator circuits, yeah, they're on isolation, red bag. If you see blood in the circuit, red bag. Otherwise, just normal trash.
Will bacteria grow in the humidifier and contaminate the patient's lungs?
Oh, that's not supposed to be there. It's supposed to be on the last page. So skip that paragraph and then go to the next part.
How to place a circuit with a heat and moisture exchanger on the ventilator. Connect the circuit and filters to the ventilator. All connections in respiratory care are done with a push and a twist. This will prevent accidental disconnections. You also want to be able to disconnect the connections. Never use force when connecting tubing.
Okay. So putting the circuit on the ventilator, we're going to start off with the filters. And like it said, everything you connect, you don't just place it on there. So with my Inspiratory filter, do I just place it on there? And the answer is no. As soon as there's pressure, it's going to pop off. So when you connect, it's got to be a push and then a twist. You see, not so strong that the next person can't get it apart, but it's got to be like a firm connection. So all your connections in respiratory care are push and twist. It says HME and then it says aerosol. So when it's time to give HME, aerosol. So when it's time to give a breathing treatment, you'll just turn this lever to aerosol, and you notice how you can see right through. So it bypasses the HME altogether so medicine can get through. And then when the treatment's finished, you turn it back to HME. So that's a bypassable HME. Here's another HME, and apparently you see this one around a lot. It's tiny, isn't it? How it can accumulate warmth and moisture, re-deliver it on the next breath. I don't know how efficient it is, but you will see this one around a lot. All right, so when you're placing the HME in line, it has to get exhaled air so it can trap the heat and moisture, and it needs to get inhaled air so it can re-deliver it to the patient. So should we put it on the inspiratory side, the expiratory side, or on the Y?
On the Y.
Yes, very good. So it goes on the Y. And we'll use this one for now.
Now that's not orientation dependent, right? That can be any which way you want to.
Yes.
Although an HME, heat and moisture exchanger, is at best about 80% as efficient as a heated humidifier, it is used on patients who are on ventilators even if they are on a ventilator for a long time. The HME traps moisture and warmth from an exhaled breath. The moisture and warmth will be redelivered to the lungs when the expired air from the next breath passes through the HME. Adding an HME increases the amount of dead space in the circuit. HMEs also increase the patient's work of breathing. This increased work of breathing resistance occurs when the patient attempts to pull in their inspired air through the HME.
So it is harder to breathe through an HME than if there was no HME. Is that a reason to not use one? No. So it still gets used. It's a very inexpensive way to provide humidity to the inspired air.
Can the vent overcome some of that extra work of breathing by delivering more pressure?
Yeah, actually it can. Yeah, very good. Pressure support with a spontaneous breath.
Select an HME that can bypass so medication can be delivered to the patient. Keep in mind that medication cannot penetrate an HME. Either a standard HME will have to be removed while the medication is being delivered, or an HME that has a bypass feature should be used.
Okay, we already talked about that. Keep going.
Inline closed system suction catheter. Place the inline catheter along with its adapter directly on the endo tube. There are some interesting features of the adapter that holds the inline catheter. The swivel is designed to prevent the endotracheal tube from being pulled when the circuit is moved. Another interesting feature is the squeegee type device inside the adapter that cleans mucus from the catheter. Along with the rinsing action of saline and the squeegee device, the catheter can remain clean enough for up to 3 days before there's a buildup of bacteria on the catheter. The number of days varies from one manufacturer to another.
So when you take the inline suction catheter out of the package, it should tell you how many days that it's good for. Does this one tell you? No. A 1-day sticker. Okay, so maybe this one's good for 1 day. So every 24 hours you would throw away the one that's in there and then put a clean one in. So it says that it has to go right on the endo tube. So there, you'll never add anything between here and the endo tube. It's just always going to go directly on the endo tube. Okay. So when you suction, it goes into the endo tube.
And where's the squeegee part again? It's inside of here, so when you pull
Oh,
the...
I'm sorry, I didn't show that to you. When you look in there, you're looking for like a clear donut surrounding the catheter.
And that's the squeegee.
Let me see if my camera can pick it up. Can you pick that up, camera? Yeah.
So when it's coming out like...
There's the nebulizer adapter and nebulizer 30 centimeter, 12 inches from the endo tube. Also called the valve T adapter. This adapter is placed on the ventilator circuit and allows a standard medication nebulizer to be added to the circuit. The spring inside will be pushed up by the nebulizer, which allows medication to be delivered to the circuit. When the nebulizer is removed from the valve T adapter, the spring expands and closes the port. This works to prevent air from leaking out of the circuit when the nebulizer is removed. A larger amount of nebulized medication particles enters the lung if the nebulizer is placed further away from the endo tube. Further distance allows the particles to become suspended in the flow of air going through the circuit. Particles that are suspended in the flow of air will travel further instead of depositing in the circuit or the endotracheal tube.
Okay, let me show you the valve T adapter that it's talking about. So when you look in there, you see a spring. When you're putting your nebulizer in, it's going to push up on that spring and then the port opens so the medication can go in the circuit. When you take the nebulizer out, this comes down and seals this. So it's time to give a treatment. You push it in. course, you hook up your oxygen supply tubing to your flow meter, turn it on to 8 liters a minute, run your nebulizer. When the medication vial is empty, then you'll take this out, and then you just cap it to keep it clean. So that's your valved T adapter. And then it's telling us if you place this further back from the endotube, you actually get more of the medicine going into the lungs. Isn't that a crazy thought? Wouldn't you think like the closer you are, the more medication you get? And it's opposite. The further back you go, the more medication becomes suspended in the flow of gas, and it'll travel further down the endotube and into the airways.
Actually, that makes sense, actually.
Did you say the nebulizer was there?
So I can show you.
Sorry, I'm visual.
Oh, that's a good question. I want to see it.
Yeah, because I
the
think
same
she
with
said
what
that.
I-
I'm looking at the piece and I'm like, I don't see.
It actually goes to HME, switch it over to aerosol,
Oh, okay.
and then we're going to add this on the inspiratory side.
Oh, see, I would have never figured that out.
Getting air still?
Did you say something about this being for nebulizer?
The saline and the MDI.
Oh, okay.
Yeah, to instill saline, if you need to instill
Oh,
saline
okay.
when you're suctioning, it goes here.
Okay.
And to add a meter dose inhaler, you could add it here, but it's not. You even see it all the way back here when you're at the hospital. Because the further back it goes, the more medication actually reaches the patient.
Then you disconnect it from there.
All right, so this is what you most commonly see. And the reason is they don't carry the bypassable HMEs, at least not at Broward Health, not at Memorial. So if they don't have a bypassable HME, they choose to put in the HME and then put the adapter where they can add the medicine and it goes into the patient. And they don't have to take this out of line. They can't bypass it. So remember what I was telling you, when you set it up like this is how the least medication gets delivered to the airways.
Oh, then that's how it's.
But that's what you see when you're at the hospital. So this is most typical. Expiratory side, then it will get delivered. Typically, MDIs get ordered when a patient's getting ready to go home. If they're going home on the ventilator and the family's going to be doing it, it's usually MDI that goes in line with the circuit. Theory of what we know. And so that you would just wait for the ventilator to deliver the inspiratory breath. So when you hear it start to go in, you just press. The medication gets suspended in the air and then it travels to the patient.
Okay.
Okay, what's next?
Untitled CO2 adapter. Place the Untitled CO2 adapter between the Y and the endotube. The adapter stays dry and needs less maintenance if placed behind an HME. By using infrared technology, an Untitled CO2 adapter can be placed in line with the ventilator circuit and can measure the amount of carbon dioxide that is exhaled from the patient's lungs. To get a proper waveform, the adapter needs inhaled air and exhaled air. The adapter may need to be taken out of the circuit on occasion and replaced with the dry, clean adapter.
What the heck?
Suspect a buildup of water, medication, and debris on the adapter if the monitor waveform appearance changes. Call your instructor to check your
Okay. So I'll show you this one last thing and then I'll take it all apart. And I need to see each one of you put the circuit together.
Okay.
All right, so Untitled CO2. It's measuring the amount of carbon dioxide being exhaled. Really important value when you're monitoring a patient on the ventilator. So the Untitled CO2 that I have here is a separate monitor. But when you're in the ICUs, they have it either with the cardiac monitor or they can have a module on the ventilator and you can observe it on the ventilator. Normally I give you guys a filter to make a mouthpiece. So each one of you can breathe and we can look at your tracing. But because we have to keep masks on, I'll skip that part for today. All right, so when you're putting the adapter in line, anytime moisture gets in here, it messes up with your waveform. So what I recommend is you put the adapter between the HME and the Y. So you'll get your inspired air, bringing everything down to 0, and then your exhaled air will come through, and then you'll see the CO2 climb during exhalation. If you put it closer to the patient, it gets wet, you have to change it quite often. So this would be okay, but you end up having to change this tubing a lot. When you're connecting the circuit to an endotube or to a tracheostomy tube, you can't just put it on and push, because it pushes the tube into the patient's throat, or here it pushes it into their neck, and you can just see them wince in pain. It's just really uncomfortable for them. So you have to support. So the endotube, you'd hold on to the endotube and then connect. With the tracheostomy tube, you can hold the flange, you can hold the inner cannula, but you have to hold something before you connect. And then when you push and twist, you're just pushing between your finger and you're not pushing into their neck. And then to release this, I kind of hold it with my first two fingers and I use my middle finger to push away from the tube. Does that make sense? There's probably a better way. Oh, it's not my first two fingers. First and third. And then I push away with my second finger. Try to separate it. So the less you wiggle their tube, the more comfortable they are. That's it. So now I'll take it all apart.
Let's put it all together.
Plug the humidifier into an electrical outlet. Alright.
Put the humidifier on.
Add Fisher and Paycal water chamber to the humidifier by sliding it into place. Remove caps from the top. Oh, the cap's already been removed?
Yes.
Connect the tubing to a bag of H2O labeled as sterile H2O for inhalation.
And then you want to close up?
You have to make sure those are open to the sterile water, so that way the sterile water can make it to the humidifier.
Oh, got it. When you look inside the water chamber, you will see the blue float, white float. Okay. Blue float controls H2O level. White float is a backup float in case blue float malfunctions. As water fills the chamber, it will stop filling when the bottom of the chamber is covered with water. What causes the water to stop filling? The float. And then what is the purpose of the black line on the water chamber? I forget.
Fill line.
Fill line. Use the ventilator arm to support the tubing while you are connecting all of the tubing. This will prevent the tubing from hitting the floor and becoming contaminated. Tubing. Alright. Place the bacteria filter on the inspiratory port. It's already there. Connect inspiratory limb of the heated wire circuit to the humidifier. Alright, and then connect the expiratory limb to the circuit to the exhalation port on the ventilator. And then use 12 to 18 inches of large bore tubing. Connect inspiratory port on the ventilator and humidifier. Explain how air flows through the circuit, beginning with the ventilator inspiratory port.
This is the 12 to 14 inch large bore tubing.
Oh, I see.
And then this goes into the inspiratory, because that's what the patient's breathing in. So when it goes through, this is the part, this is where it's going to go through here. It's going to go through the humidifier to get the humidified air to go through the tubing to the patient. Then when it comes through back through the expiratory port, it'll come through patient to expiratory port and back into the ventilator.
Ready to connect the temperature probes and sensors and the heated wires. They are coded by size and color to prevent wrong connection from occurring. First, connect the blue and yellow connectors to the side of the humidifier.
Match the, so you see the arrows? You match the arrows until it clicks.
Oh. Okay.
You got arrows again?
Bottom connection blue is for the temperature cable. You will notice that the cable has two sensors. Plug the sensors into the proper ports. One sensor is plugged into the circuit, where the circuit attaches to the water chamber. It sends information back to the humidifier about the temperature and flow at the point in the circuit. The longest end connects into the port at the patient Y. Make sure it is on the inspiratory side. This sensor senses the temperature of the inspiratory gas right before it enters the lungs. If the temperature reads below 39 degrees Celsius, the heater wires will turn on. If the temperature is above 39 degrees Celsius, the heater wires will turn off.
You see it over here?
Oh, sorry.
Yeah.
Let me put that here. And that's to the patient.
Well, this is all to the patient. This is to sense the temperature to maintain. Make sure it doesn't go too hot or if it's too cold. Okay? What's the next step? Thank you, Gretchen. You're welcome.
Number 2, the top connection's yellow is the attachment for the heater cable. You will notice the cable has 2 plugs. Attach one plug into the inspiratory side, the other plug connects at the expiratory side at the end of the tubing. These wires heat up the circuit.
And then if you want
The
to...
purpose is to prevent cooling of the
got
gas.
1, 2, 3
A gas that cools as it travels through the circuit can produce condensation in water.
Question, are they the same? Like it doesn't matter which one goes in the...
One is a 2-prong, one is a 3-prong.
Oh, okay.
So that's connected, and then this one's the 2-prong.
Oh, I
2-prong.
And that one's going to go over here to there.
Okay, turn on the humidifier. In the front panel of the humidifier, select the invasive mode. The invasive mode is used with a patient that has a bypass upper airway with either an endotracheal tube or a tracheostomy tube. Locate the alarm silence. Locate the digital readout where the water temperature is displayed. You have completed the humidifier setup. Place an inline closed system suction catheter into the circuit.
Suction catheter.
Not suction cup.
Yeah. I'm just gonna,
Why, I've heard.
I'm just gonna go upstairs and get a snack.
Okay. You could leave it over there for that. We're not gonna...
Okay, place a nebulizer with a T adapter and in line with the circuit.
So the nebulizer treatment?
With the T adapter in line with the
This
circuit.
goes before. Bye, Yvonne. Bye, take care of you.
Good job. Ta-da! You did it.
Yeah, that looks great.
Yeah,
Now you
good
can
job.
take it all apart.